Okay, so I just wanted to talk to you about hypothesis testing. Um, so this is basically the grand finale. This is why we've been doing everything that we've been learning throughout the class. We put everything together, the probability, you know, the different types of distributions, and we kind of interpret things and make judgments about things. And so this allows us to test claims about things and based on parameters like standard deviation, mean, and proportions of things and such. So that being said, you need to know some language. We've got a null and alternative hypothesis, and then we've got to explain type 1 and type 2 errors and state conclusions about hypothesis tests. So we're going to go through all that in just the first part. There isn't actually a homework set about this, but I will make sure that it's clear what you should understand about all this. So a hypothesis is a statement regarding a characteristic of one or more populations. In this chapter, we're going to look at, in this chapter, we're only going to look at one population, but and I think the next chapter 11, we talk about comparing two different ones and determining things about them. Examples of claims regarding a characteristic of a single population. In 2008, 62% of American adults regularly volunteered their time for charity work. A researcher believes that his percentage is different today. So, what that means is the null hypothesis here is that we assume that it's called null because there's no change. So we would assume that h naught, which is h sub 0, which is an h with a little 0, and I'll draw that for you, is equal to 0.62. We always use decimals when we talk about hypothesis. And then the researcher's hypothesis alternative, which is your h sub 1, is that he believes the percentage is different today. So there's three different possibilities. You can believe that it's less than it was, you can believe that it's greater than it was, and you can just believe that it's not. It could be either greater or less than, just that it's not equal to 62. And so there's three different tests or three different possible hypotheses, and you can actually put those into the calculator and use the calculator to help you with that. So according to a study in March, the mean length of a cell phone call was 3.25. Researcher believes that the mean call has increased. So in this case, we'd have your h naught being equal to 3.25, and then it's increased, so you'd have your h sub 1 where the mean is greater than 3.25. So it's not very difficult to figure that out. The null will always be equal, and then something else will happen, either greater than, less than, or not equal to. Okay. Using an old manufacturing process, the standard deviation of a bottle was 0.23 ounces. With the new equipment, the manager believes that the standard deviation has decreased. So obviously in this case, you'd have sigma being equal to 0.23, and then that's for the null hypothesis. H naught is H naught, and then you'd put a colon. You'd have sigma is equal to 0.23, and then you'd have H1 colon sigma is less than 0.23 for your alternative hypothesis. If population data are available, there's no need for inferential statistics. So if they give you a list or something, we can actually put the list into the calculator and use that data to do these things to hypothesis test. And you do have to still have your null hypothesis and your alternative, but you don't actually know the standard deviation or anything. The calculator will calculate it for you. So the hypothesis testing is a procedure based on a sample, evidence, and probability used to test statements regarding the characteristic or of one or more populations. So the whole process, once you do everything, is called a hypothesis test. Steps in hypothesis testing. So you make a statement regarding the nature of a population. So you decide if it's less than, greater than, or not equal to. You collect evidence, and then you analyze it using a calculator. And then you basically decide based on the evidence with your with your significance level, whether or not you can keep your claim or make your claim with whatever confidence that you have. The null hypothesis, this is your H naught that I've been mentioning, is a statement to be tested. So this is always when you have, it's either the mean is equal to something, the standard deviation is equal to something, and the or the proportion is equal to something. Alternative, denoted H sub 1, is this, and this is the one you're trying to find evidence to support. Okay, in this chapter there are 3 ways to set this up. We have two-tailed test. That's when, this is obviously when it's left or right. This is when you have either greater than or less than. So you have your H naught being with your parameter being equal to a value, but this is your H1 being not equal to. This is when I said not equal to earlier. Two tests, that happens when it's not, it doesn't matter if it's greater than or less than. It could be either. You have your left-tailed, that's when it's less than. Obviously, you can see your parameter is equal to something with the null. It's always equal to with the null. And then it's less than. This is when they say like it's the standard deviation was less than or whatever it was earlier. We talked about that. And then obviously your right-tailed test, this is when it's greater than. And we're going to be using a calculator to do this, so it shouldn't, you'll just have to match the signs. So in other words, the null hypothesis is a statement of the status quo or no difference and always contains a statement of equality. The null hypothesis is assumed to be true until we have evidence to the contrary. We seek evidence that supports the statement in the alternative hypothesis. Parallel example 2. So for each of the following, determine whether it's two-tailed, left-tailed, or right-tailed. So we just look. A researcher believes that this percentage is different today. That means that it's two-tailed because that means that it's not equal to. It doesn't matter if it's greater than or less than. A researcher believes, this is part B. A researcher believes that the mean length call has increased, so that's greater than. That would be right-tailed. And then with the new equipment, the quality control manager believes it's decreased. That would be left-tailed. Okay, and we kind of draw the picture so that we know if it's left-tailed, right-tailed, and all of those things. So they actually did a little bit more of the work. You can pause it if you want to see it. I talked about this a little bit before. H naught P is equal to 0.62. P is not equal to 0.62. H naught mu is equal to 3.5. Mu is greater than 3.5 for the alternative. That's what they said in the statement. And then finally, sigma is equal to 0.23 or sigma is less than 0.23, and you got left-tailed. Okay, so there's 4 outcomes. Reject the null hypothesis when the alternative hypothesis is true. This decision would be correct. Do not reject the null hypothesis when the null hypothesis is true. So you get a couple of different outcomes, and it's based on what your p-value is or your critical value. You can reject the null when the null is true. The decision would be incorrect. Obviously, you don't want to reject it if it's true. And then you do not reject the null when the alternative hypothesis is true. This decision would be incorrect. This type is called the type 2 error. I don't ever ask you about type 2 errors. I don't ask you about type 1 errors. I'm not so concerned with that in this class. So we're going to go through these. We're going to get rid of these. We don't need this. Okay. So the level of significance is important. This is alpha. The level of significance comes from the confidence interval. If the level of significance is 0.1, then that means the confidence interval is 90%. It's just the complement of it, right? Because 0.9 plus 0.1 is 1, so that's how I know the confidence interval is 90%, because if it's alpha is 0.1, what gives me 1 with it? We never accept the null hypothesis because without having access to the entire population, we don't know the exact value of the parameter stated in the null. Rather, we say we fail to reject the null hypothesis. This is just like the court system. We never declare the defendant innocent, but rather say not guilty. Okay. So according to, we're going to state the conclusion. According to this, we got a mean. A researcher believes that the mean length has increased. Suppose the sample evidence indicates that the null hypothesis should be rejected. State the wording of the conclusion. I think that a good way to say that is we reject the null hypothesis, which means there's sufficient evidence to support that the mean length of a phone call has increased from 3.25 minutes. And then for the next one, suppose the sample evidence indicates that the null hypothesis should not be rejected. We would say that we fail to reject the null hypothesis. There is not enough evidence to suggest that the mean length has increased. Okay, so the statement of the alternative hypothesis is that the mean is greater than. Since the null hypothesis is rejected, there is sufficient evidence to conclude that the length is greater than this. Okay, and since the null hypothesis is not rejected, there is insufficient evidence to conclude that, so we can't say that. Okay, and with that being said, that's the end of this video. We'll move into hypothesis testing for proportions next.